this problem, we're going to try to find the exact value of this expression. So we should be able to do it using some identities. You'll notice there's a cosine squared and a minus, but it might not be something you recognize. So the trick is to recall that there is an identity that looks very similar to this one. It says if you have 2 cosine squared x minus 1, that's the same thing as cosine 2x. So this is the same thing. This is an identity from trigonometry. So here you see that you don't have a 2 and you have a 1/2. So what you can do is you can use this identity to come up with this. So let's go ahead and divide everything by 2 here. And then what happens is you end up with 2 cosine squared over 2, which is just going to be cosine squared x. I'll skip a step. Minus, and then 1 over 2. And that's equal to, and I'm going to write this as 1/2 cosine 2x. I did that pretty quickly, so let me explain it again. So basically, we're just dividing each piece by 2. So if you divide the first piece by 2, you get this. If you divide the -1 by 2, you get this. And then you divide this by 2. And remember, dividing by 2 is the same thing as multiplying by 1/2. So now all we have to do is plug in the pi over 8 into our new formula. So this is the cosine squared of pi over 8 minus 1/2, right? Just replacing x with pi over 8 so we can do this. And so this is equal to 1/2 cosine of 2 times x. And our x here is pi over 8. So this is the key step. We're just applying this new identity which we created from this one. And then this is equal to 1/2 cosine of pi all over 4. So this is equal to 1/2, and then the cosine of pi over 4 is the square root of 2 over 2. So this is equal to the square root of 2 over, and then 4. And that would be it. That would be the exact value. So I think the trickiest thing in this problem is knowing what identity to use. But if you know this one right here, 2 cosine squared x minus 1 equals cosine 2x, then you can kind of say, hey, wait a minute, there's a minus, there's a number, there's a 2 missing, and there's a 1/2 here, so it's almost there. Let me write this down and play with it, see if I can make it match this, and then apply it to pi over 8. I hope this video has been helpful. Good luck. Hi, in this problem we're going to find the exact value of 4 times the sine of 15 degrees times the cosine of 15 degrees. So the first thing that you should notice is that you have a sine times a cosine. And so if you notice that, then you might also remember that there is a very powerful identity that says if you have the sine of 2x, that's the same thing as 2 sine x cosine x. So this is a very powerful trigonometric identity. So here what you can do is you can pull out a 2. So I'm going to go ahead and rewrite the problem just so I have more room. So 4 sine 15 cosine 15. And then I'm going to go ahead and pull out that 2. So this is 2, and I'll use a bracket just to really try to add some clarity. And we're left with 2 sine 15 degrees cosine 15 degrees. And then we have a bracket. So you see here, you can apply this formula directly, which is really, really cool. This is a really cool problem, I think, because it's kind of cool. It's fun that we get to use this identity, I think. And then so x here is 15 degrees, so that's this one here. And you see we have the 2, we have the 2, we have the sine, the cosine, so it all matches. So this is equal to 2, and then right here, the sine 2x, that's what's going to go here. So it'll be sine of 2 times, and then x is 15 degrees. So 15 degrees. So then this is equal to 2 sine of 30 degrees. And then this is the part where you just have to use, your memory. Hopefully you have this memorized. So the sine of 30 degrees is 1/2. So this is 2 times 1/2. So it's equal to 1. So that would be the final answer. I hope this video has been helpful to someone. Good luck. In this problem, we have to write this as a single trigonometric function or a number in exact form. Solution. So here we have to use an identity. It's a double number identity. The identity we're going to use is the one that looks like this. Cosine of 2x equals 1 minus 2 sine squared of x. And we're using this one for obvious reasons because we have a 1 and a 2 and a sine squared. So let's go ahead and do it. So 1 minus 2 sine squared of 22.5 degrees. So our x in all of this is 22.5, right? That's our x. So this is equal to cosine of 2x. So 2 times 22.5. So 2 times 22.5 is 45 degrees. So this is equal to the cosine of 45 degrees. And the cosine of 45 degrees is the square root of 2 over 2, and that's just from memory. I hope that made sense. Write as a single trig function or number. Solution. In this problem, the identity we're going to use is cosine 2x equals cosine squared x minus sine squared x. So all we have to do is replace all of the x's with 15 degrees. So we'll start by writing down the original question, which was cosine squared of 15 degrees minus sine squared of 15 degrees. And that's equal to cosine of 2x. So it's 2 times 15 degrees. So this is equal to cosine of 30 degrees. Right? It's because x is 15, so you get 2 times 15. That's how we got that. And then 2 times 15 is 30. And the cosine of 30 degrees is the square root of 3 over 2. That's just from memory. And that's the final answer. I hope that write as a single trig function or number in exact form. Solution. So in this problem, we have to use one of the double number identities. So the one we'll use is the one that has a sine squared. So cosine 2x is equal to 1 minus 2 sine squared x. So we'll start the problem by writing down the original question and then making it look like this identity. So I'll rewrite the original question. So 2 minus 4 sine squared of 15 degrees. So to make this look like this, we just have to pull out a 2. So 2 parentheses. So we need 1 minus 2 sine squared of 15 degrees. This is equal to 2, and then now we'll use our identity. So 1 minus 2 sine squared 15 degrees, that's the same thing as cosine, and then x is 15, so it's 2 times 15 degrees. This is the same thing as 2 times cosine of 30 degrees. And the cosine of 30 is equal to the square root of 3 over 2. So this is 2 times the square root of 3 over 2. The 2's cancel, and so we end up with the square root of 3. And that's the final answer. I hope that made sense. In this problem, we're going to write the sine of 15 degrees times the cosine of 15 degrees as a single number or a single trig function. Solution. So whenever you have a sine times a cosine, a common identity that you can use is sine 2x equals 2 sine x cosine x. Because you see here you have a sine function and you also have a cosine function. That's what we have here. We have a sine and we have a cosine. The only thing we have here is this extra 2. So what we'll do is we'll divide both sides by the 2. So now these go away, and so we're left with sine cosine. So I'll write it over here, sine cosine. And that's equal to sine 2x over 2. But we can write that as 1/2 sine 2x. Now we're good to go. All we have to do now is replace all of the x's with 15 degrees. So sine of 15 degrees times cosine of 15 degrees is equal to 1/2 sine of 2 times 15 degrees. This is equal to 1/2, and then 2 times 15 is 30. So sine of 30 degrees. And sine of 30 degrees is 1/2. That's just from memory. It's really important to have these values memorized. So 1/2 times 1/2. And so the answer is just 1/4. So again, whenever you see a sine times a cosine, it's a good idea to think of this identity here. That's it. I hope that made sense. Hello, in this problem we're going to find the exact value of 2 minus 4 times the sine squared of 15. So the first thing that you might notice is that both of these have a common factor of 2. So let's just go ahead and start this problem by factoring out a 2. So 2, parentheses, and then 2 times what number will give us 2? Well, that would be 1. And then minus 2 times what is going to give us all of this? Well, just 2 and then sine squared of 15 degrees. I'm going to go ahead and put parentheses here just because I like it better. It just looks better to me. I don't know why I didn't write it originally. It doesn't really matter, but I like to add them. So at this point, there's an identity that comes to mind. Recall that if you have the cosine of 2x, that's equal to 1 minus 2 sine squared x. This is an identity from trig that we're going to use in this problem. So here, what's happening is we still have our 2, and then our x here is 15 degrees, you see? That's our x. And so you see it's here, there's the 2, there's the sine squared, there's the 1, there's the 1. So all of this is all of this down here, okay? So then it's just going to be cosine of 2x. So cosine of 2 times, and our x is 15. So 15 degrees, just like that. Really, really nice. So this is equal to 2. I'm going to go ahead and write it again out here. Just, I feel like it's trapped. So 2 times 15 is 30. And plus it's good to multiply. And now we just have to figure out the cosine of 30 degrees. Well, the cosine of 30 degrees is simply the square root of 3 over 2. So this is times the square root of 3 over 2. These cancel, and so you get the square root of 3. For many people, one of the hardest parts is figuring out what the cosine of 30 degree actually is. Let's just talk about that briefly, because I think it'll be maybe a little bit instructive, because I think this is a thing that a lot of people have a hard time with. Obviously, if you can use a calculator, you're okay, although it's going to give you a decimal. Many people end up memorizing that decimal simply so they don't have to memorize the square root of 3 over 2. So the sine of 60, okay, the sine of 60 is the square root of 3 over 2. And 60 in radians is the same as pi over 3. 30 in radians is the same as pi over 6. And then the sine of 30 is 1/2. So how do I know that? Because if you memorize just one of them, like say you just memorize this one, once you know that the sine of 60 or pi over 3 is the square root of 3 over 2, that means that the sine of 30 is the other one, so it's 1/2. Because these are the two that people often mix up in their minds. So memorize one, and then you know the other one is 1/2. And then here it's simply reversed. So this one's 1/2, so this one has to be the square root of 3 over 2. Likewise, these can't be the same, so this is 1/2. So it's a cheap trick to memorize all of these angles, cosine of trig function values rather, cosine of 30, cosine of 60, sine of 30, sine of 60, or same thing, pi over 3 or pi over 6. You can memorize all of that simply by memorizing one. A bit of a tangent there, but hopefully, if you're still watching, that's helped you in some way. And hopefully this video has helped you on your trigonometric journey. Good luck.